Welcome to the next video in the mathematical logic sequence, talking about propositional logic, and in this video talking about unique formula reconstruction. As a sort of intro to what we're even talking about here, consider, for example, this sentence P1 conjunction P2. If I tell you that it is a conjunction sentence, I think it's fairly clear what I'm saying when I say that. I'm basically telling you that it is the result of taking some formula and some other formula and putting them together in the construction rule that constructs the conjunction. And it stops there, right? So the conjunction is the main connective, said another way. Now let's do it all over again with the slightly more complicated sentence where I put a negation in front of that. I can now tell you that this is a negation, which could be a little less clear exactly what that means, because if you're not super sharp on your sort of talking about main connectives, well, you might say, well, in what sense is that a negation when, after all, it's also got a conjunction symbol? But when I say that it's a negation, I mean that like the main operator in some sense is the negation, that fundamentally it is the negation of some sentence. The fact that that underlying sentence is a conjunction is the sort of like, that comes later in some sense, right? The first level description of the sentence is that it is a negation. So this is a demonstration, basically, of what we mean by unique reconstruction. The idea being that, in a sense, if I just gave you a sequence of statements about what is the main connective, and then what is the underlying sentence, where the underlying sentence is again given in the same way, right? So if it has no main connective, then you just say that it's an atomic sentence and you say which atomic or formula it is. Whereas if it has some connective, you identify the main connective, right? In some sense, the most recent construction rule applied, right? So that would be negation, conjunction, disjunction. And then you tell me what the underlying sentence is. And again, right? How do you do that? Well, you tell me, if it is atomic, you tell me which atomic. And otherwise, if it's not atomic, then it was formed from some construction rule, negation, disjunction, conjunction. And then you tell me which one it is and what the underlying sentence is, and you go so on. That's the idea, right? So if you just give me this sequence of statements about what the most recent construction step was and what the underlying sentence was in this way, you can use this sequence of steps to say which sentence we're talking about. Just in case this is at all confusing, I feel that sometimes when a statement is a little too obvious, it's a little hard to tell what we're even claiming. And this feels like a fairly sort of obvious thing that almost doesn't even bear stating, perhaps. So just to sort of illustrate what's at stake with the claim here, let's see actually a case where it fails, right? Then it maybe seems a little less obvious that this always holds. So take, for instance, basically the same definition of formulae that we've already given, except that we drop the parentheses in our constructions so that P1 conjunction P2 conjunction P3 could be constructed through our construction steps. Likewise, P1 conjunction P2 disjunction P3. And now we'll see how uniqueness fails in this particular setting, right? I mean, in some sense, what this kind of demonstrates is why our construction rules really insist on having these seemingly superfluous parentheses on the conjunctions and the disjunctions. If we didn't have that, technically, we would fail this unique reconstruction property, which would be very bad. So let's take, for instance, let's first examine this P1 conjunction P2 disjunction P3, and let's notice that you can't say that this is a conjunction or a disjunction. You may be thinking, oh, but don't these operations have sort of, rules about binding precedence, and then you can? Well, we're not there yet, right? We're not establishing that, so we're just imagining that we don't have any precedence rules, and we're just thinking about, these things in terms of the construction steps that were taken to arrive at them. So in this particular setting, you could have constructed this particular sentence through two different sequences of constructions, right? The reconstruction is not unique because you could have just constructed P1 in the sense that we already know that that is a formula. And then you could have constructed P2 disjunction P3. Okay, so you first construct P2, then P3, then P2 disjunction P3. Now you have these, and then you construct their conjunction. That's one way that you could have arrived at this. And the other way that you could have arrived at this is you could have first constructed the conjunction, and then with the conjunction in P3 construct the disjunction of those. And so, right, these are two different construction sequences which arrive at the same place, so the reconstruction is not unique. Now, I want to point out that there's really kind of two different senses in which a construction can fail to be unique, and we just saw one of them, where in some sense the sort of like failure of uniqueness is what the main operator is, right? In the previous one we saw that you could have a single expression which could not reasonably be called either a conjunction or a disjunction because the most recent conjunction step is not determined, right? It could be one or it could be another. But there's another form of failure, right? Uniqueness or its failure, which is which sentence is the subsentence. So here, take P1 conjunction, P2 conjunction, P3. Well, here we can say that this is a conjunction. There's no doubt about it, right? If it was constructed one way or another way, in both cases, it was most recently constructed by a conjunction. The failure of uniqueness is which sentences are the subsentences that were used in that construction step. So in one case, it could be P1 on the one hand and P2 conjunction P3 on the other hand, or P1 conjunction P2 on the one hand and P3 on the other. Okay, so I know I promised that these videos would be very sort of mathematical and proofy, but this really, the proof is so simple that I feel like it would be a bit of a waste of time. I am amenable to if there are requests to fill in certain blanks like this, if anything is confusing, or if I'm choosing to skip something that you'd rather see not skipped, then leave a comment and I may fill in the gaps. Who knows how punctual I will be about that.